Hi, everybody. We are going to look at this particular problem, which will help us look at intercepts and slope and understand that a lot of times they have context to them. We've already looked at two different scenarios where you could look at slopes in different ways, and now this video is going to be adding in the whole concept of intercepts and seeing what they look like. So here is our problem. The Sandia Peak Tramway in Albuquerque, New Mexico travels a distance of about 4,500 meters to the top of Sandia Peak. Given the table, identify the slope and the intercepts. What do they mean given the context of this problem? All right, so let's look at this. We have x, which is apparently in minutes, and f of x, which is in meters. And we have values in this table. It looks like my x values aren't going up at a consistent rate. So the biggest idea here is that we're going to have to pay attention to, is there a consistency in this table? Like, do we truly have a slope that we can actually decompose here? So let's look at our y values or our f of x values and compare them to what we have in our x values. So 4,500 to 3,900 is going down by 600 meters. 3,900 to 3,000 is going down by 900 meters. We're then going down by 1,500 and another 1,500. If we look at our x values, we increased by 2 minutes, increasing by 3 minutes, increasing by 5, and increasing by 5. So now what we need to do is we need to compare these numbers from our y values to our x values, or f of x values to our x values, and see if there's consistency there. So do these all equal the same rate? Do they all equal the same ratio? If we compare them, are they equivalent? So negative 600 over 2, is that equal to negative 900 over 3 is the question. Is negative 900 over 3 the same as negative 1,500 over 5? Now we know negative 1,500 over 5 is the same as negative 15 over 5, or 1,500 over 5. So we know those are equal to each other, but are those also equivalent to negative 600 over 2 is the question. So if we divide this by 3, divide by 2, divide by 2, this one, divide by 3, divide by 3, this one, divide by 5, divide by 5, do we get equivalent ratios out of this? Negative 600 divided by negative 2 gets me divided by 2 gets me 300 over 1. Negative 900 divided by 3 is negative 300 over 1. So this is already looking promising. Negative 1,500 over 5 gets me negative 300. 5 divided by 5 is 1. So our slope in this problem, our m, is negative 300 over 1. And now we need to understand what that means. That means I'm going to put a label on it. So this negative 300 is our meters. So it looks like we're going down 300 meters for every 1 minute. So I'm just going to add a little bit of a label. We are decreasing in this situation by 300 meters per minute. Now, what do the intercepts mean? You'll also hear me say, what do the zeros mean? That means that I am going to go into this table and find when x is equal to 0, and I'm also going to go into this table and find when f of x is equal to 0. So when x is equal to 0, we're at 4,500 meters. So to put that in context, that essentially means if I were to graph this, my y-intercept, 0, 4,500, is this point. So that's the highest point. This is like the top of Sandia Peak for this tram ride. Okay, so that's essentially what that is saying, top of Sandia Peak. And then if we look at this other one, 15 over 0, that means the meters wise, we're at 0. So we've hit the bottom of the mountain and it's taken us 15 minutes to do so. So that x-intercept, 15, 0, is telling me that it takes 15 minutes to do that entire tram ride. So this whole thing, it takes 15 minutes to do the tram ride from top to bottom. And technically, we wouldn't increase, or we wouldn't go back in time and we wouldn't go into the negative distances. But we can see my x-intercept is 15 minutes. That's the context of this particular point. My y-intercept, the context of that particular point, is 4,500 meters, which means it's at the top of San Diego Peak. And when you go down in this tram, it'll take you 15 minutes if you travel at this 300 meters per second down from the top. Kind of cool, huh? Intercepts are fun. That's essentially what we're getting at. So now I want you to try the must-do practice problems, and please start into the exit pass when you're ready. Thanks. Bye.